Hey, welcome back. I want to talk to you a little bit about what we did before, what we did in the last part, in part one of this video. We were actually in this other tab. I copied everything into one spreadsheet just to make it a little bit easier. We generated these two graphs. And what we're going to do for the protein data is we're going to essentially generate the same two graphs. But we're going to have one little twist in there. So let's go ahead and copy, color the things that we colored in the other video. Since you saw me do that, I'm going to do this really quickly because you already know how to do this. And you have all these done this way. And then we'll color in all of these standards, and let's make it light green. Okay, so what we're going to do is the top value in our standard curve for the protein concentrations was 2 milligrams per mil. So I'll put a 2 here. And we'll go equals this one divided by 2 because we did a twofold serial dilution. So you have that value, and we'll go all the way across here. Okay, so next thing to do is to finish generating the standard curve. So we want to do is equal to average, equal AVER. And we want to average the mean of these two values. And what we'll do here is, since we can just copy over, we'll do that. So now we have the mean. So now we have a standard curve for protein. And what I always like to do is I like to go ahead and look at the curve to verify that it's a good curve, the parameters are right. Remember, I told you to look to make sure things were linear and things like that. That's what I want to do. So I'm going to hit Insert and Charts, hit this value right here, and we'll right-click here, add a trend line, and we'll add an equation and R squared. And it's got a very good R squared. Anything above 0.99 is actually a very good standard curve. This looks pretty good. And what I'll do here, just out of habit, label BCA standard curve, because sometimes if you do a lot of these, you're doing some scenario planning and things like that, you wind up not knowing what graphs were and where they came from. Even though there's some tools to do that, it's still a little bit difficult. I just go ahead and label things to prevent that from happening. Well, now that we know the curve looks good, we know what the slope is, and we know what the y-intercept is, let's go ahead and calculate them as well. So let's go ahead and do the intercept and the slope. So the intercept is equal to enter. And what we have to do is we have to do all the y values first. Oops. All the y values first, comma, all the x values. Hit enter. And you see 0.157, 0.157, looks good. Slope is equal to slope. And we copy the same y values first, comma, and then we do all the x values, hit enter, and we get that 0.775, 0.775. Looks good. So we know the curve is good. Let's go ahead and finish calculating the protein concentrations. To be a little bit lazy and take advantage of what we did before, what I would do is go to this one and just copy all these fraction names. Control C or Command C. And just paste them in. It's there. So the first value we're going to do is wild type protein absorbance. So I know what it is. Here, we'll go ahead and put an equal sign, put that in, hit enter, and copy it to here because we have the two load samples. The next is to put in the sample, enter, and then we drag across all the way to 0.15. Then here we do an equal sign again, put this value in, hit enter, and we copy them all the way to here. Didn't copy everything before. Okay. Oops. Okay. So next thing we need to do is we need to take advantage of calculating. We need to calculate the amount of protein from the standard curve right here. So wild type concentration of protein is going to be equal to, remember, y equals mx plus b fit the line. So we want to solve for x. So it's y minus b, which is the intercept, divided by the slope. Have that there. So we have the y minus the intercept. And remember, we want to keep that in place. So we go ahead and put that here, because we have that as a fixed value. We'll close the parentheses and then divide by the slope. We want to keep that fixed in place, so we do shift 4, and there. And to go ahead and calculate across, just drag it across. It does all the calculations for us. And what I'll do is I'll copy that to be yellow, because these are the calculated values for protein concentration. So this is mutant protein absorbance. I'm flying through this because I went slower through this in the past. Equals this value, hit enter, cross, put equals, it'll be this value, hit enter, these values, and then here is equal to this value, hit enter, and go all the way across. So now we go ahead and we want to determine the mutant protein concentration. So we'll do this. We'll do that equation again. Y minus b divided by slope. So it's equal to the quantity, this value, minus this value. We need to fix it in place. Whoops. Wrong spot. Needs to go before the K. Oops. What? And before the 11. And close off the parentheses here. And divide by the slope. And we want to fix that in place as well. So it's shift 4. Shift 4. Hit enters. And here we go all the way across. And what I'll do here is, since this is calculated values, I'll make these blue. Okay. So now we have all these concentrations, all these things calculated. And now we need to go ahead and incorporate that onto the graph. And probably there's a couple of different ways to do this. You might be able to just copy paste all these numbers, but there's kind of another way to do this. Go to the enzyme data, put it in equals there, go to protein data, and the first cell there, hit enter, and we can drag all that across and see it's all those same values, and then we copy all the rest by going down this way. So we do that. They all come in, they come in all the same number of figures, significant figures, and all that sort of stuff, but the colors don't come with it. So let's go ahead and the calculated values, let's color them, because it's going to make life easier for us to see the colors, because there's a ton of numbers here. Oh my gosh, these values come in. If For some reason, the data was already in here, but I think maybe from a practice session. But let's go ahead and remove these data points. Just click on them. It gets rid of them. Okay. Now we're going to go ahead and add that data in. I'll show you how to do that, even though it looks like I already had done it before, but let me take you through the steps. So let's do the wild type, the wild type first. So we'll go ahead and click Select Data. What I did in the past is I clicked Edit and I added the name Enzyme Activity, and that's good. Then I need to add, and then I'm going to add in wild type protein. And then I'm going to click there and highlight all of this data. Click that right there, go in, click OK, click OK. And what you see here is you see a little bit of orange in here. You may see that, but it's because the two scales are so different, is it assumes it's all using just this one y-axis over here. But what we do is there's a function here in change chart type, and you can have an idea what had happened. You click combo, hit secondary axis, and there the data will be in place. Now let's go ahead and do that for the mutant. So we'll go ahead and select data. I clicked edit mutant activity words there, and now I need to add data in. And here we'll go ahead and click there. And it's this one, this, and click this data right here. Click OK. Click OK. You see a little bit of orange in there as well. Well, we have to do the same thing again. It's because the two things are very different scales. We need to go ahead and use that combo feature again. So, oh, sorry. Cancel. Change chart type. Go to combo. Click that box right there. You see all the values come in place. Click OK. And you see we have a nice little graph here. And we have all those things in here. One of the nice little features you can do to these graphs is to add the axes labels and things like that. I'm going to label one of them. I'm not going to label the other one for this video, but if you want to put them in your report, I would label both of them the same way. We have that selected. Go ahead and click chart element. Put the legend. I personally like the legends off to the right side as well. It's just a thing, people put it on the bottom and things like that. It's wherever you think it's your decision to make. That one is perfectly, there's no right answer, no wrong answer, but the legend is good because it tells people which one is which. Now we'll go back to chart element, axis titles. We're going to click primary horizontal and type fraction number. Click the check mark. What happened? It didn't happen. Fraction number. We have that there. Now let's go ahead and add this axis here, the one on the left-hand side. Axis titles. This is the primary vertical, and it's going to be in terms of micromoles. It's going to be per unit of time for however long you did your assay of P in P, which is paranitrophenol, which is the yellow color that was the product of the reaction. So you have that there. Now let's put the axis on this side. Go ahead and click that element again, axis titles, secondary vertical, and I would put milligrams per milliliter protein in the sample. And there you go. You have a completely labeled graph. I would do the other graph as well. But that's all you need to do. So whenever you come into class for experiment number 9, you need to have these 2 graphs with you, and then I will sit down with you, or the TA will sit down with you, and we'll talk about which fraction you need to choose to do your enzyme kinetics assay. So hopefully this was useful to you, and if you have any questions, feel free to send me an email, drop by office hours, or before or after lecture class. We'll see you later. Bye.